Welcome to Building Programs, Building Brains, Bridges to STEM Learning for grades kindergarten through 8. This training is brought to you by BOSTnet, Build the Out-of-School Time Network, and the UMass Boston College of Education and Human Development, with support from the Department of Early Education and Care in Massachusetts, and brain building is in progress. This is Interactive Presentation 1, What is STEM? STEM stands for Science, Technology, Engineering, and Mathematics. This acronym STEM has become very common in the world of education for encapsulating these 4 different subject areas that are very distinct from one another but also closely interrelated, as we'll be exploring in the rest of this presentation. Of these 4 categories or topics, science, technology, engineering, and mathematics, mathematics is the first topic that we're going to discuss more, and the reason for that is because math is the foundation upon which the other 3 are built. In the Massachusetts curriculum frameworks, mathematics also gets its own curriculum frameworks, whereas science, technology, and engineering are contained within the same curriculum framework. Mathematics is the study or use of numbers and shapes to calculate, represent, or describe things according to Macmillan Dictionary. Mathematics is a really important skill that is foundational to all of the other STEM topic areas. It can be very, very theoretical, but the core value of a math is that math allows us to understand and quantify and represent the world around us, which is something that we need to be able to do in order to apply science, engineering, or technology type concepts. So it's a very, very important foundation. Core skills in math that are outlined in the Massachusetts curriculum frameworks include adaptive reasoning, which is the ability to adjust and adapt your thinking to a problem as that problem changes or evolves over time. Strategic competence, which is the ability to formulate, represent, and solve mathematical problems. So the ability to take the problem in front of you and represent it as a mathematical problem, and then figure out how to solve that problem. Conceptual understanding, which is having a really firm grasp of the various concepts of math, like addition and subtraction, or geometry, or calculus. Procedural fluency, which is the ability to apply the specific procedures, like being able to do various operations, such as solving for x, or adding 2 numbers together. And then productive disposition, which is very, very important, which is the thought process of believing that math is a useful and important tool that can be applied to solve problems within the world. The next element of STEM that we're going to take a look at is science. So in the Massachusetts curriculum frameworks, science is covered within the STE curriculum frameworks. And it is a series of different theoretical approaches to understanding the world around us and how it works. Science seeks to understand the natural world and often needs new tools to help discover the answers. This is from the STE curriculum frameworks from 2006 in Massachusetts. Core skills in science include being able to generate and ask questions. All exploration in science starts with a question and then proceeds through the process of attempting to answer that question using a scientific method. From asking questions, the next core skill is developing and using models. And this might mean literal models like a model that you assemble, or like how a toy car is a model of a real car, or it might mean more theoretical models, such as using mathematics to model what happens when you drop something or throw something, using physics to model how a ball moves through space when you throw it at your friend during baseball. The third element of science is planning and carrying out investigations or experiments. Experimentation or investigation is a huge, huge part of science, and it's a great opportunity to get kids more excited and engaged with science in general, because it's generally quite fun. The fourth is analyzing and interpreting data. So that means that whatever information you capture when you do your experiment, you then need to work on learning how to take advantage of using that data. Then next is using mathematics and computational thinking. So this is why we started by looking at mathematics, because in order to effectively use science, you need to be able to use some of those core concepts from math to make sense of your data, to compute and analyze your answers more effectively. The next core skill is constructing explanations. So this means that you try to figure out why things happened the way they happened in your experiment. After that comes arguing from evidence. So this is using evidence and logic to construct an argument for what happened and why it happened, and to draw conclusions from that. And then finally is evaluating and communicating information, which is sort of an underappreciated piece of science that has a really nice overlap with the ELA, the English Language Arts piece, the speaking and hearing and the logic. Okay, so we've looked at mathematics and we've looked at science, and now it's time to take a look at engineering, which I think I always get kind of excited about because I feel like it's a very important piece of STEM, and yet somehow it seems like for most programs and most educators, it's the most difficult piece to quantify and to figure out how to include in your program. So don't worry, we'll be tackling that in this course. Engineering uses scientific discoveries to design products and processes that meet society's needs. It's important to remember that engineering refers both to products, which are physical things, and to processes, which are approaches or strategies. So not all engineering is physical. This comes from the STE curriculum frameworks for Massachusetts from 2006. So if you look at this list of core skills in engineering, perhaps you'll notice that most of them are absolutely identical to the core skills that you saw in science. Engineering and science have a lot of similarities in terms of the underlying skill set, the underlying principles associated within them. The differences are those two that are sort of highlighted in a paler teal color, defining problems instead of asking questions, and designing solutions instead of drawing conclusions. So engineering is more concrete and more applied. Instead of asking a question and looking for explanations or conclusions as a result of the experimentation that you do, in engineering you start with a problem and you solve it. So it's definitely more targeted than science. But you'll see that a lot of these other concepts, developing using models, planning and carrying out investigations or experiments, analyzing and interpreting the data using math, arguing from evidence, and evaluating and communicating what you end up learning, those are all the same from engineering to science. So as you explore science and engineering, it's good to think about the links between these two as well as the differences between them. Okay, so now it's time to take a look at the fourth and final letter in our acronym of STEM, which is technology. Technology is the most applied of all four elements of STEM, and we'll take a look at what that means now. Technology, products, and processes are the result of engineered designs. They are created by technicians to solve societal needs and wants. This also is from the STE curriculum frameworks for Massachusetts from 2006. So you'll notice that technology, just like engineering, is made up of products and processes. But where engineering is conceptual, it's how to create the products and processes and what the products and processes should be, technology is the actual stuff that you build after the engineers have finished their work of figuring out what the solution to the problem is and should look like. So there's a big connection between engineering and technology. Technology comes out of engineering. So some types of technology could include instructional technology, which is both the equipment and also the strategies that we use in order to be successful at teaching people stuff. Assistive technology, which is technology that helps people to accomplish things, and that includes assistive technology for people who might have special needs, but it also includes other types of assistive technology. An extremely simple example is that a step stool is assistive technology for becoming taller. Medical technology, which again spans a really, really wide range of stuff. Information technology, which is any technology that helps us access or use information. Transportation technology, again, technology that helps us to engage in transporting ourselves or other stuff, so trains, planes, cars. rocket ships like the one you see here. Then construction technology, which is technology that either helps us figure out ways of building stuff, strategies for building stuff, or that actually helps us to build things. So it could be tools, or it could be structures or strategies to create new things. Communication technology makes us more successful and effective at communicating, or helps us to communicate more broadly or across a broader audience. And then a number of other kinds of applied technologies. In fact, because technology is the result of problem solving, new kinds of technology are evolving over time. We didn't really have communication technology 10,000 years ago at all. Communication technology was you open your mouth and words come out. But then writing got invented, and that was the first type of communication technology out there, and we've been going ever since. So new types of applied technologies are being created all the time, which is very exciting.